Okay, hope you have a graphing calculator handy. We're going to read through this and we're going to interpret it and make sure we understand what it's asking. So here we go. We should pace ourselves to, we have 2 problems in 30 minutes. So we should pace ourselves to be about 15 minutes per problem. Water is pumped into a tank at this rate. Let's pause right here. I think it's worth noting and worth saying that this is going to be N. The W function is N. Measured in liters per hour. Notice everything as you read. For 0 to 8, where T is measured in hours, water is removed from the tank at a rate modeled by R of T, liters per hour. R is differentiable. That's going to come in handy later. I'm making notes as I go. Because this is differentiable, it is therefore also continuous. We are going to need that later. Just giving you a heads up. And it is decreasing. I want to underline that because that's going to come in handy. And I think it's going to be fairly obvious that the numbers are decreasing, but they are telling you that the numbers are decreasing, which means that in between we don't have these spikes where it goes back up. This is consistently decreasing because they said so on that interval. Now, back here, water is removed from the tank. So if W of T is in, then R of T is out. Making all kinds of notes. Selected values of RT are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. Let's jump in. Estimate R prime of 2, show the work that leads to your answer, and indicate the units of measure. So clearly we're dealing with the R function, and we want to know the slope at 2, and we don't have the luxury of actually knowing the value at 2. So that is why they're asking us to estimate it. So this is going to be an average rate of change. So number 1, part A, R prime of 2 is going to be basically the slope around 2. So it's going to be 950 minus 1190 divided by 3 minus 1. So we'll just crank out an answer very quickly on that, and I won't waste too much of your time. That's negative 120. So we need to indicate the units of measure, show the work that leads to your answer. So here's our work. There's really not much to show beyond there to jump into this. And we also need the units. So knowing that we are taking the derivative, not technically, but we're dealing with the slope, I should word it that way, of R. This is liters per hour, so we're going to put liters per hour, but we're taking the derivative with respect to time, so it's liters per hour per hour. That's part A. Here goes part B. Use a left Riemann sum with the 4 subintervals indicated by the table to estimate, this is an estimate, the total amount of water removed from the tank during the 8 hours. Let's stop and do that. We'll read the rest of it later. So here goes. Let's find our left Riemann sum. And if you look at the answer key on this, you're going to see that they write things in this very unique way. I don't think it is required for you to write this, but I do think it's nice to put it in context. We are not finding the integral, but we are finding a quantity. And so we can demonstrate this quantity this way. This is not equal to anything that we know for sure, but it is an estimate. So I think it's just kind of handy to say, you know what, we are approximating a quantity because this is the integral of a rate. And we're going to do a left Riemann sum. So here goes. We're going to go from 0 to 1. That's a width of 1. Oh, excuse me. I felt that coming on. A width of 1 and a height of R of 0, which would be 1340, plus a width of 2 and a height of 1190. There's your second rectangle. A width of 3 and a height of 950. And a width of 2 and a height of 740. And we're going to proceed with this, and we're going to end up with 8,050. And they also want us to find the total amount of water. They did not ask for units, but I'm going to put it anyway. Okay, have not finished part B yet. So we only read the first sentence. Here we go. Is this an overestimate or an underestimate of the total amount of water removed? And give a reason for your answer. Ha, glad you asked. There we go. Let's find the appropriate note card. You have your note cards. And I found this one. So when is a left or right Riemann sum an over or underestimate? So before I flip this card over, I'm going to think logically, because this is something that I don't necessarily have to memorize. It should be somewhat logical. And here it goes. If we are decreasing, and I'm going to doodle over here. This is totally not part of my answer, so don't even think this is part of the answer, but this is an explanation. If I have a function that is consistently decreasing, I'm just making up a bunch of dots. They're not necessarily linear, just doodling. And I do a left Riemann sum, then I'm going to have an overestimate. And I drew 5 rectangles, there were 4, but you get the general idea. So here we go. I'm going to have an overestimate for a left Riemann sum on a decreasing function. And notice where we underline decreasing. It's good to know. So let's write an explanation. This is an overestimate. And why? Because the function is decreasing. It is strictly decreasing. Sometimes they put the word strictly in there. Okay, let's read part C and see what we're up against. Use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, so we have water in a tank, and we're going to be taking water out, and we're going to be putting water in, and we're going to be doing this for 8 hours. So there is kind of an easy setup that we can come up with here, and it's going to be this. So here's the total. The total amount is going to be, well, 50,000, I almost said dollars, that's not it, 50,000 liters, and we are going to pump some water in. Well, how much are we going to pump in? Well, we are going to pump in water at this rate. So I need the integral of this from 0 to 8, okay? The integral from 0 to 8 of w of t dt. If you want to write the actual function, 2,000 and e to the negative t squared over 20, that's fine. But we're also going to be dumping some water out, taking some water out, and I'm going to subtract the answer from part B. So we removed this many liters of water. Now, it is an estimate. So this is exact, this is exact. They say it was modeled, so we'll go with exact, but this is totally an estimate. Very much an estimate. And because, well, let me back up and say this. Sometimes you can leave your answer like this and just be like, yeah, I'm done. But you're going to need this answer later. They did want you to actually find it. So we're going to do that. So let's start typing, and we'll see what we can come up with. Good thing this is calculator active, because finding this integral would be nearly impossible otherwise. Let's see what functions we can put in here. I'm going to put w of t in there, which is 2,000 e to the negative t squared over 20. And that is correct. I said t squared. I typed in x. That is okay. We'll go with that. Not going to hurt a thing. And so let's start typing. 50,000. Count your zeros. Make sure you're right. Plus the amount of water in, so math 8, we're going to go from 0 to 8, math 9, I'm sorry, function integral, and we're going to choose y1, that's alpha trace, and dx, we're using x, not t, and 80, 50, and I should get, looking at the answer key here, 49,700, yep, there we go, it matches. Now, they said to the nearest liter, so I don't need to use 3 decimals. I say always 3 decimals, but they said don't use 3 decimals, so let's just round it to the nearest liter. Read that carefully. 49,786 liters. Okay, part D is where things get a little bit tricky, and I'm going to pull out a note card here that is a little bit unexpected. So I think part A, part B, part C are a little more straightforward. Part D is where things get a little tricky. And for 0 to 8, is there a time t when the rate of the water is pumped into the tank is the same as the rate at which the water is removed from the tank? Explain why or why not. Okay, whoa, what, huh? So here's what they're asking, and I'm going to just start writing out some thoughts, and we're going to go from there. They are basically saying, is there ever a point where this, oops, let's make that a t, not an x, is equal to this for some time between 0 and 8, including 0 and 8, inclusive. Okay, is this ever true? That's what they're saying. And I'm kind of rewording the question here. So let's start moving some things around, and you'll really see where this is going. I really feel like you will see where this is going. So just start experimenting if you don't know what you're doing. It's okay. And I am actually doing this backwards from the answer key, but that's okay. So they're asking this, so really they want to know, is this true for some value between 0 and 8? Make that an 8, there we go. That's what they're wanting to know. So that's not wrong, this is the question, but this is the question. This question mark had 2 dots on it. So, I don't know. What are they asking? Now, I'm going to just take this down to the bare minimum. They're asking for the existence of something. The existence. Does this exist? I don't know. If I need to know if something exists, I need to go to my existence theorems, and I have 3 of them. Extreme, mean value, and intermediate. We are dealing with slopes, but on the most fundamental level, they are saying, is this true? Does this exist? And I just want to know about the value. So watch this, and if it's not clicking yet, that's fine, but just watch, and you'll see what's about to happen. Before I flip this card over, I need, just remember what's on the other side of it, I need to meet 2 conditions. I need this to be in between this and this, and I also need continuity. Okay, let's flip this thing over. The function is continuous. Now my function is really 2 functions subtracted, and there is some number between, 0 in this case, between f of a and f of b, between 0 and 8. So I want to figure this out and this out, and if one of them is positive and the other one's negative, and we have continuity, we can play the intermediate value theorem card, and that's exactly what we're going to do. All right, so r of 0 minus w of 0, let's find out what this is. R of 0 is 1,340. I'm looking at the table when I write that. When I plug in a 0 into the w function, I get 2,000. Let's rearrange some equal signs here. Where's my whiteout? Ah, it's gone. Okay. Can't find my whiteout. It's all right. Let's not waste time looking for it. And this is going to be a negative. All right. R of 8 minus W of 8. Well, R of 8, I'm looking at the table, is 700. And W of 8, I don't know what it is, but I have the function in there. So alpha trace y1 of 8. And that gives me 81. All right, 81 and some change. 81,524, let's do that. And I really don't care what that is. I just care that it's positive. All right, we have crossed boundary number 1. Boundary number 1 was, do we have betweenness? Actually, it's boundary number 2. Do we have betweenness? Yes. 0 is between this negative number and this positive number. Do we have continuity? Yes. Yes, we do, and here is why. All right, because I'm just going to start writing the answer. Because R of t is differentiable, because I said so. Remember when we underlined that at the beginning? Differentiable. It is continuous. W of t is inherently continuous. Just look at the function. This is a continuous function. You never divide it by 0, you're fine. It is also continuous. So R of t minus W of t is continuous. All right, let's talk about some other stuff. We have continuity. We have betweenness. Also, hard for me to say. Also, R of W minus W of R of 0 minus W of 0 is negative, and R of 8, sorry, minus W of 8 is positive. So because 0 is in between, the intermediate, I don't know why I capitalized the, I'm excited apparently, the intermediate value theorem applies. And there is a t in the interval from 0 to 8 such that r of t minus w of t equals 0, I'm going to go one step further and I'm going to say this. We have answered the question. This is what they wanted to know. This is how we started reworking it. All right, we've gone a little bit longer than 15 minutes, so we might have to trim that off in some other places. Let's grade this thing. All right, let's look at the scoring guide. And for part A, we needed the estimate and we need the units. And every free response question is worth 9 points. And so we are going to retrieve or get 9 points in this, not retrieve. We're going to get 9 points. So that was worth 1 point and that was worth 1 point. Okay, part B. The left Riemann sum setup was worth a point. So we got a point here. And if you're looking at the scoring guideline, and the scoring guidelines can get a lot more detailed than what you see on this paper. They have pages and pages of this. You could also get credit for that or that. And they also have the actual estimate, so we needed that. They did not ask for units, so we're not going to make a big deal out of it. But they also wanted the overestimate with a reason. So this is an overestimate, and we had to say why. You can't just get credit for saying it's an overestimate, and this is why. So we have earned 5 points so far. Here comes part C. We need to have the integral and the estimate. So the things they were looking for in this was, did you ever show this? Now, instead of w of t, if you would have put the actual function, that is fine. It's the same thing. So we got credit for this right here. And then, because we set all this up correctly and we typed it in, we also got credit for this. They did not ask for units. Okay, part D is worth 2 points, and here they are. They said, and I did mine backwards. You will get credit for that, though. Considers w minus r. I did r minus w. Folks, you are going to get the same thing. It's going to be fine because we still had the same rationale. So my signs are going to be different here because we reversed them, but we considered w minus r, or in my case, r minus w, and then the answer with the explanation. So all this is worth another point, and I just want to take a green pen, go through here and highlight a few things, underline a few things. Answer with the explanation, you better include the intermediate value theorem. And along with that intermediate value theorem, you better have some betweenness. So, and you also need to have some continuity. And I believe this is really attached to it's differentiable, therefore it's continuous.